Hello everyone, today we will learn how to connect a V COMM LoRa gateway to a sensor. But before that, let me introduce what is a LoRa gateway. A LoRa gateway, also known as LoRa base station or LoRa concentrator, is a gateway device that utilizes LoRa wireless modulation technology to achieve long-distance data transmission. It is positioned at the core of the LoRa star network and serves as an information bridge between terminals and servers, with multi-channel transceiver functionality. The devices today we are going to use in this operation includes an A V COMM AP100 LoRa gateway, which is the LoRa RTU Client, an A V COMM AP144 LoRa gateway, which is LoRa RTU Host, also known as the LoRa End Node, and an A V COMM Modbus liquid level sensor. First, let's configure the AP100. Power up the gateway and use a USB to micro data cable to connect it with your computer. After connecting, open up the device manager on your computer and find out the port number of this gateway. As you can see, the port number displayed here is COM10. Next, open our LoRa utility debugging program. Select COM10 in COM and click Connect. In the pop-up interface, enter your username and password. Here you can choose between USB or 485 in communication modes. Here, we are using USB cable, so we will select USB and then click Login. Here, let's jump into a little introduction to this software. If you click on Tools interface in the top left corner and select Options, it lets to set the parameters to set the corresponding serial port. Under the same Tools drop-down, if you click on Settings, it shows you the current device's version, serial number, address, and lets you toggle the options like current hold, voltage hold, and the rest you can see on the screen right now. Now, let's configure the AP144. Power up the gateway and use a USB to micro data cable to connect it with your computer. After connecting, open up the device manager on your computer and find out the port number of this gateway. As you can see, the port number displayed here is COM9. Now open another window of our LoRa utility debugging program. Select COM9 in COM and click Connect, then enter your username and password in the pop-up interface and hit Login. Now, if we compare both interfaces of AP100 and AP114, we can see that AP114 interface has an additional I/O option, which is there to set the input and the output of the connected sensor we are about to set up. The Modbus sensor we are using here is A V COMM WS101LL, which is a liquid level sensor. To power it up, according to the product manual, we will use an integrated 2-wire current wiring. Here, we connect the red wire to the positive terminal of the power supply, and the blue wire to the channel 1 port of AP144 while completing the circuit by connecting it to the negative terminal of the power supply. On your computer, open the LoRa utility I/O interface of AP144. As shown on the screen, select channel 1 and click Read. If you see any data value in the current input, it indicates you have made a successful connection. Next, we need to build a wireless connection between AP100 and AP144. Firstly, assign the device Modbus address to 1 in the serial interface of AP100 and click Write. Since the AP100 will serve as the central unit, it needs to collect data from other LoRa gateways. Assign the device Modbus address to any number within the range except 1. Here we are assigning it to be 3 in the serial interface of AP144 and click Write. Note that the device Modbus addresses need to be unique. In addition, it is necessary to ensure that the rest of the parameters are consistent, such as baud rate. Then, click on the Group Net option for both devices. In AP100, select the destination ID 3 in the Group Net interface and then click Write. In AP144, assign the group owner ID as 1 and then click Write. Here, you can see we selected AP144 as the destination in AP100, and AP100 as a group owner in the settings on AP144. Also ensure that the other values for this option are consistent. In the LoRa interfaces, we also need to check whether the values of all parameters are consistent. After the inspection, we can observe if the communication light of the LoRa product is flashing. The signal light only flashes when LoRa product is actively reading the data. Hence, here your connectivity between AP100 and AP144 has been established. Finally, in order to access the live data from AP100 on your computer screen, we need to use a 485 to USB data cable. After connecting both, open up the device manager on your computer and find out the adapter identity, which over here is COMM11. Open ModScan32 software, click on Connection Settings, select COMM11, and then click Confirm. In the main interface, assign device ID as 1, which refers to the device AP100. Under the Modbus point type drop-down, we will choose the desired register. Here we are selecting 03 holding register because our desired data is stored in this one. Finally, we can view the values on our computer screen corresponding to the input from sensors. We do it via using the Modbus register codes. These codes can be found in A V COMM LoRa Gateway User Manual under the chapter Modbus RTU Protocol, Register Control Table. To test, input the desired address and observe if the LoRa light of the gateway the values on your screen change. If the LoRa light is flashes and the values start changing in accordance with the sensor's input, it indicates a successful connection, and the LoRa gateway AP100 is wirelessly acquiring data from the sensor via its wireless connection with AP144.